Hello everyone. I welcome all of you to the day 5 of AI and ML session. For an important instruction here is that filling the attendance form is very much mandatory, as I always say. And also, many of you have doubts regarding the assignments. So I just want to tell you that we haven't assigned any assignments till this point. So please don't worry about the assignments. And a quick recap of what we studied in the last class. We studied about probability. Then we had a discussion over types of events in a probability. Then we discussed about Bayes' theorem, marginal probability, and also we saw the implementation of like plotting the graphs on the Jupyter notebook. So I hope you all have installed Jupyter notebook on your system. So sir, welcome sir, and I think we can start with the session.
Yeah, thank you so much, guys. Good evening once again to all of you from my side. And, very greatly, Gargi has recapped all the things what we were discussed in the last session. And continuation to that, we are going to, have a discussion on a great thing, which is, very, very interesting, machine learning concept. And which is actually reinforcement learning techniques. I hope that everybody can able to see the screen, and I hope my voice is audible. If anything you find difficulties, just post it and we'll make it rectified as soon as possible. I think from our end everything is fine. I think so. Okay. And meanwhile, so we came across like what exactly the supervised learning and supervised learning, reinforcement learning, how these have been categorized. That was the thing we were discussed so far. And here we just have a glimpse of how the reinforcement learning is being working, or let me take it as in that way, the working principle of reinforcement learning, or I could call it as the conceptual view of the reinforcement learning. All right. So I try to make you all understand exactly what is actually reinforcement learning. And before that, many of you says like, good evening, and somebody says, attendance form not active, and everything will you be getting perfect, right? So you can check it little later, or in a couple of minutes. That would be fine. Okay. So have you all have any idea about reinforcement learning? Because in the introduction session itself, I have given some little notion of how reinforcement learning is going to be. All right. So again, I can give a very simple example. As I've given the same example in the introduction classes about the when we are talking the categories of the machine learning. Let us take a born baby. All right. So certain things are humans are teaching, like maybe the mom or dad is, or their relatives is guiding the child, like you have to go that, come this way, because even though whatever you'll be guiding, the fresh born baby will not able to understand what you are talking. Am I right or wrong? So, though you are instructing, though you are guiding, because the instruction, the guidance cannot be understood by the child, when the child is born. That is the reality, right? Because the child never knows this is English, that is Hindi, that is Marathi, that is Gujarati, that is Telugu, that is Tamil. It never understand what is this. It's simply the baby always looking. That is the situation. So how the a baby is learning, how the learning is going to be happen, the environment. Am I right? Because uh, in terms of a baby, according to the baby, even the the mother and father is also your environment, right? Even that baby never recognizes she my mom, or she is the dad, all right, or he is the dad. So everything is going to be feeded by the environment, uh, at every day-to-day life, that baby is looking or learning something, because we are thinking like baby is being grown or is being cultured by the parents, but not actually the truth. The truth is environment is guiding, or environment is teaching everything to the baby. All right, I hope you got to understand. So according to the baby, all right, so if you make any machine, if you want to keep some machines, the machine is started learning from the environment. What is the environment? Everything. So the environment, because the any events is going to be happen for a certain reasons, right? The any events is going to be happen for a reason. The reasons, I could say, a task, because what is the outcome of a reason? The task is going to be done. So when something is going to be executed, or some task is going to be implemented or done, so this machine should be reacted, right? Should be reacted. If the machine is reacted in some way, that by that way, or by that learning, if the task is gets completed, then because the machine should get a price, right? Because it's very quite common thing, right? So I could put in other way. All right, so that is a same born baby like, and there is a mom. There is a mom is here, and let us assume that this is a fire. So I'm not good at drawing, just manage it. It's a fire. All right. So the mom is watching, the baby is actually playing. What is the event he is doing? The baby is doing is she's playing. When she's playing, all right, unfortunately, you are so far away from the baby. This fire is so close to the baby. The baby is started to move towards to the what fire. Then how the mother of the baby is thinking? So she was so tense, and she was so she feeling very bad if if our baby goes and touch the fire, so the baby gets injured. So that is shouting, don't go there, don't go there, but the baby never listens anything, because the baby doesn't know anything. So simply goes here, right? So when he goes here, all right, and if the baby touches the fire, so the baby gets injured. So that is a one way of learning. So the baby learns, that is the fire, because this is the environment. Where the environment, this particular events is being learned by the baby. That is the one thing. The second part is, if your baby goes and touches the fire, what will be the action of the mother? The mother gets tensed, and she's coming and she's taking out of it's taking the baby hand. The mother is scolding him. So the mother is actually scolding. Mother is actually a scolding. All right, the scold is actually, I can say, in terms of a machine, I could say it is a penalty. I could say penalty. So the baby gets to know, if I go close to the fire, two things is going to be happen. One thing's, I was so injured. The second part is, the mother is scolding. So that was the learning by the baby. But according to the environment gives a penalty of a mother, because mother is the one who can take care of the baby, right? So the it's you get penalty. The baby get penalty. So maybe the mother is beating or something. It's a get penalty. Let us take the other scenario. Next day, the baby is there, similar to the same situation. The baby is playing. Then there was a fire. The baby is it's not going to the fire. Instead, the baby is it's coming towards the mom. Then what the mother is doing? So mother is actually it's taking the baby hand. She is and she is showing her love actually. So that is actually a reward. That is the rewards, right? Because instead of going close to the fire, the baby comes close to the mother, then the mother gives so love, because it's showing a lot of love to the baby, so that you can consider rewards. So when the mother gives a rewards, all right, to the baby is learning, if I go far away from the fire, then I'm going to get so much of love and affection from the mom. So how it happens, because it's a situation, it's an environment, because everything happens in a environment, right? So here I couldn't say like the mother is the only one who can teach everything to the baby, because not mother, because the mother is one of the parameter or one of the metrics over there, but the environment is started to teaching to the baby, so how the rewards and penalty is going to be taken out, right? Because the baby starts learning, because it itself start learning, because when the same situation is going to be happening, that's what reinforcement learning, because again the things is going to be recollected, because all the possible states of the action is going to be registered in its mind, right? The baby mind, of course, right? So here everything is going to be represented as a states. In the reinforcement learning, the environment, inside the environment, everything is states. The states is going to be gets activated. So when the state gets activated, there will be a possible actions. What is the possible action? The baby goes to the mom, or whether the baby goes to the fire. That was the possible actions. So every possible action, there should be a penalty and there should be a reward. All right, that's it. So just to have an idea, a reinforcement learning is it's a learning mechanisms. By that way, anyone can take a decisions, because anyone in the sense the machine, because the machine is, if you're not programming the programmed, that machine is actually the empty, right? Empty mind. So the empty machine starts learning, accordingly it will start reacting. How the reaction is going to be happen? The reaction is actually, I could say, it's a decision, right? That's what I've mentioned here, making decisions. You should just listen carefully. So making decisions. All right. So reinforcement learning is, it's all about taking a decisions based on the environment returns. What actually the environment is returning? Environment is returning you as a reward, as a penalty. If your action is done for a positive reasons, then the rewards are going to be given to you. If the actions what you'll be performing, it gives a bad things, then penalty is going to be given. So that is the kind of process the reinforcement learning takes care. All right, that's it. So at every step actually, because it is not a one step actually, because the born baby never learns at a first actions, because if the baby goes close to the fire, even tomorrow if you come and place the fire, again the baby goes close to the fire, because by learning the environment at a n number of times, that's what sequentially, at the n number of times, then only the baby gets adapted the the outcome of the actions. All right, fine. So what actually I can say in a nutshell is, reinforcement learning is a kind of mechanisms wherein which things are going to be learned in a plenty of iterations. At every iteration, there will be a learning outcome. Based on the learning outcome, the further decisions are going to be taken. Right? You can map this problem for a playing a chess. Right? Because playing a chess is not so easy, as I said in the previous session. At every move is it's going to be a much complicated, which means that every move has a lot of hypothesis. So you are here to take a decision. The decision has to be so wisely, it will carry you, or it will take you into the winning directions. All right. So completely, because if you have been played a 50 times, you never learn. All right, because even if you are a so genius, or if you are so brilliant, or right? You cannot learn all the things because you have to travel along with the environment by which you'll be learning the different possible kinds of outcomes, because there will be a plenty of state migration. Every states will be learning the things. All right. I hope you got to understand what exactly. So what we are going to look in this chapter is particularly how the process is going to be happen, how the rewards are going to be maximized. So as much as the rewards are going to be received, then you are in the right direction of the problem solving. And what exactly the markout decision process, what is q learning, and finally demo. So we are not going to discuss the demo because we are not going to talk about the coding part. I just try to give you a glimpse of reinforcement learning. I think the introduction, I hope that you all got to understand what exactly the reinforcement learning. All right. So sorry, now I take you into the another presentation that is exclusively for reinforcement learning. Okay. So whatever I've just explained, everything I'll be listing out here. All right. It is a sequence of decisions. So the agent learns to achieve a goal in an uncertain, potential, complex environment. Which means, what is actually agent here? Agent is actually the baby, which is learning from the environment. That's it. All right. So in case if you consider it as a computer or as a machine going to be puts in the environment, and via the trial and error method, it starts learning. By that way, the problems are going to be solved. And you can see here the rewards or penalty for the action, for every actions what the agents are going to be performed, and you'll be getting the rewards or penalty. But ultimate aim is actually, if you receive more number of rewards, then that is the positive sign of the great learning. All right, that's it. That is what I have been given here. Lot of situations. So you take a simple scenario here, right? This is a great example for a simplest example, not great example. It is the simplest example for a reinforcement learning. There will be a path, and you have to come up here to claim the reward, right? That's the actually task for you. So when you reach here, you can claim the rewards. When you're not reaching here, when you stuck with somewhere intermittent, then you're not able to claim it. All right. So that's what the reinforcement learning. You can just map whatever I have told you. So let me take you. If you go by this way, you stuck here. If you go here and here, and if you go here, there is no, you'll be stuck. And I can take the next path. You can take this one, and if you go by this way, yeah, absolutely fine. The third one, what I have selected, this is the path to, you can claim the rewards. So this is the, learning. But again, the same agent, right, put the same problem. He never knows, like, right? He can try it out. He can try it out, come this way, you can go this, and he gets stuck up. All right. So when he starts to playing n number of times, then every times that machine, that environment gives you a rewards. So because we have just pushed the agent into the environment, because the agent has taken the 5 times of the problem solving out of 5 times, and only one time he claimed the rewards. The rest 4 times he claimed the penalty. Right. So which means that still the agent is not ready to solve the problem. Still he has a long way to learn the problem to get to reach out the rewards. So that's what I have given here. You can see here, agent learns to behave in an environment by performing actions and seeing the results. That's it. And The deep learning, sorry, the reinforcement learning is going to be applied on top of ML, similarly on top of deep learning. So we know what exactly the deep learning. Deep learning is more exclusively for multimedia, which means that you can take like a video and image and audio and etc. What exactly the machine learning? So most likely we'll be dealing here numeric data, numeric information or data, but which means that like I'm not saying like multimedia data never been handled by machine learning, but most oftenly the numeric data is the one you can solve those problems very efficiently with the help of machine learning. All right, fine. So similarly, you can make use of the reinforcement technique on top of the machine learning. Similarly, you can apply the reinforcement learning mechanisms on top of the deep learning. That's what, right? So when you have autonomously deep learning and machine learning, you may have the answers. All right. So what is the price of fuel on the next week? I know. I think fuel is the fuel prices keep on increasing as a rocket speed, right? And everybody could able to know about it, the fuel price. So that is the one of the answer. So you'll be building a model which has to be tell you what is the fuel price of March 30. So it will be given. That is the one answer of using the machine learning. The deep learning, whether you'll be walking to the your office, and there will be a model like which is automatically the image is going to be taken from the CCTV, then and automatically your presence are going to be marked by the machine learning model, that deep learning model, that is a deep learning. And so always the known answer is going to be given, right? But well in advance, the answer are going to be taken up. That's it. You know very well, definitely the price is going to be, from 100 to 200, not more than that, very well. Because in this ranges, what would be the value is going to be happen in the future things. But when you apply reinforcement learning along with machine learning, you can see the policy are going to be made, right? Which means that rules are going to be framed, and according to the rules, automatically the machine itself can take a decision. All right, so that's the very very significant impact when you apply reinforcement learning on any sort of the problem. All right, so when you design a robotics, definitely reinforcement learning is the only one paradigm which would be maximize the intelligence of the robotics. All right, so you can see another examples I have given. There will be agent at every steps is going up, it's going up, going up, going up. Then in an environment, he claims the rewards actually, right? There are two important components. One is agent, other one is environment. Agents are learning from the environment, and there are different kinds of components are there. I have just given you what exactly the agent. The agent are the one who want to learn the things repeatedly, and then it has to take a decisions dynamically. That is the actual agent. So we want to train the agent in a intellectual way. And what is the environment? So the environment might be anything where the agents are going to be, when the agents are going to be, uh, living. All right. So the environment are the one which can teach the agent, or which can give the input to the agent by which the things are going to be happen. So environment is, it's completely the surroundings where the agents are living. That's the environment. And action. So when there is a person A and there is a person B, he wants to move from this place to this place, so you have to carry some action, right? So either you should go by or bus or public transport or private or anything. So he has to go away. So that is called as action. All right. So all the possible steps or possible kind of how you'll be reaching out over there, because there will be a certain point A and B. How you'll be reaching to B, what medium or what kind of the transportation you have been taken, whether you have been directly landed over there or whether you have been broken and you have been taken the lot of different kinds of the transportation. That is actually actions, the possible set of actions and states. See, if you are traveling from some place to some other place, if somebody calling and asking you like, where are you currently? So you'll be saying, I'm not yet reached the destination, still I'm on the way, because on the way is actually state. So again, more precisely, somebody is asking, because your mom is asking, tell me where exactly you are in. So you'll be saying, where I'll be in the junction of C. C is the one places. And after some time, your friend is calling, where are you? And you'll be saying, right, D. Because if somebody says on the way, because on the way is not a right answer, right? So if somebody is so close to you, then they'll be asking the more precise answer where exactly you are in. You'll be saying the point of junction where you are in. So these are all the intermediate stages. So now the migration is going to be A to C and C to D and D to a B. All right. So this is the actual state. So every state is going to be monitored and it is going to be keep tracked. So by the environment. All right. So currently the agent is in which place? And there will be a reward, very well. So reward is always the, reward is actually the instant appraisal, right? So if you are doing the great things, if somebody is coming out and if somebody is not praising you at the time, after a month, if somebody is praising for you the things what you have done before a month, then would you get a good opinion on it? Definitely no, right? So reward is always something should be given once the action is performed wisely. That's the instant you know actions. So instant return, that is what rewards. And policy, the policy is nothing but in which way you'll be going out, because from a point A to a B there will be a lot of ways are there, and which way you'll be going out, that's the policy. The policy is nothing but the approach or the way in which how you'll be taking from your current state to the next state. All right, that is what policy. And value, because every action should have the value here, right? Every action should have the value there. That is what this one, it is an expected long-term return with a discount. So which means that, so because it is a biggest chapter, let's keep aside discount as of now. Just have an idea. The value is nothing but the action should be notified or should be measured by value. That is the value here, right? And action value, the action value is nothing but actually when something is going to be moved from one state to another state, there should be some value, right? Because you are traveling A to let us take A to B. There will be a intermediate stages like C and like D, because this distance is not equal to this distance. Am I right? So according to the state which the agent is taking, the values are going to be given. That is what action value. All right. So okay, it is a small example again for you to understand the things so clearly. And let us understand this is the actually agent. It's a fox is actually the agent. All right. So these are the rewards. So there will be a reward 1, reward 2, reward 3, and reward 4, reward 5, 6, and 7. There will be a tiger. There will be a tiger. Here actually the moral of the story is like, what is our agent? Our agent is fox. You have to train the fox in such a way the fox has to be claim the maximum number of rewards so that the agent learns everything completely. After that, the foxes independently or dynamically take decisions how the fox can have a meats, more number of meats in front of the tiger, right? So you just imagine it, because it's all wild animals, right? So everything is living in a forest, like both fox and tiger. The same meats are being provided, and even of tigers is trying to take all the meats. But what is our actual agent is actually the fox. So just imagine the fox can easily get this meat R1 and R2 because there is no tiger close to here. And whereas if the fox is trying to take this rewards, there will be a risk involved. What is the risk actually? These rewards are so close to tiger, because if the fox goes inside, goes close to this, the fox is trying to acquire the rewards, then the life of the fox might be a question mark. Because if the tiger captures the fox, that's it, that's the end of the fox life. So without losing their life, the fox has to take the maximum rewards. So what is the risky free rewards here? R1 R2 are the risk free rewards, easily the fox can take. But how the you just imagine these rewards are not been there, then definitely in order to live their life by the fox, he has to acquire the meats, acquire the rewards R3, definitely should go. So the fox has to learn when I supposed to go and acquire this rewards R3. All right, so then where actually it starts learning, where actually starts learning, if the fox takes the grab the rewards, then rewards are going to be increased. All right, so the agent should acquire as much as possible rewards, so that the performance of any machine is going to be amazing. All right, that's it. I hope you got to understand. Okay, so here there will be two things, exploitation and exploration. Exploitation is a when you have a known way, then if you chosen that path, that is exploitation, right? So very well, like let us take Mumbai to Noida or Mumbai to Delhi. Let us take that path. Somebody knows the way, right? Because there will be plenty of ways are there to reach from Mumbai to Delhi. But if you have been traveled the known way, you are exploiting the same way what you know. By that way, you are thinking that you can reach to the destination very fastly. Okay, so there won't be any risk involved when you are performing exploitation. Whereas, what is actually exploration? Exploration, you are completely no idea. You have never gone from Mumbai to Delhi in a way. You have no idea, because when you are not knowing something, but you are trying to go or trying to start travel from Mumbai to Delhi, that is what exploration. So when the way is not known by the agent, but still the agents are trying to go or trying to go and acquire the rewards, which means they're trying to go and reach out the destiny, then that is can be called as the exploration. All right. So what is exploitation here? What is exploration here? Exploitation here is this one. Fox knows these two things. He knows the fox knows very clearly. He can grab it, but the fox have no idea, have no path how to claim this one, this one, this one, this one, this one. Without without the vision of the tiger. That is what exploration. If the fox goes and takes these rewards, then he has been created a new path of acquiring the rewards. All right. Once again, yes. Oh, you see here, because you're now so far we were discussed as a logic or conception, but how this logic is going to be implemented, all right? What is the mathematical backbone that we have is Markov decision process. Markov decision is a kind of statistical view of approaching a problem. So I'm not going to discuss what exactly the Markov chain or Markov process here, all right? Because if I go into that way, then we will be completely deviating, because since it is the fundamental, I just want to give the essence of how the reinforcement learning is performing, right? So as we know, like there will be agent, there was an environment, and agent gets reward, all right, when the action is performing in a right way. So what exactly the Markov decision process is doing? The Markov decision process is mapping all the rewards as a matrix of values. All right. So you can see here we'll be looking at A is a set of states, set of actions, states, reward, policy, and a value B. So with these metrics, we'll be creating a value chain. Via the value chain, we'll be deciding how the agents are learning. Right. So see here, because this is one of the example how the Markov decision process is working. Just now I have been told you there was a B, C, D. Markov decision process basically which helps you to find the shortest way from one point to another point. All right. So there will be plenty of ways. Am I right? So you can see your 15, 50. Wherever there is a positive value, it's a reward. Wherever there is a negative, you shouldn't choose that path. It is a penalty value. All right, that's it. And what exactly the Q learning? So Q learning is a kind of a technique the Markov decision process is using to maximize the rewards. Or else, via the Q learning, all the states migration and how the agents are claiming the rewards are going to be recorded with the help of the Q learning. So simply the Q learning Q stands for actually the quality. Q stands for quality, which means that the quality learning is going to be happen with the help of Markov decision process. All right. So this is the one example, like it's a kind of a room like 0, 1, 2, 3, 4, 5. Then the goal of this problem is wherever the agent is, the agent supposed to come out, or the agent has to reach out to the room number 5. That's the goal. How you'll be coming out, that is the state of the actions. All right. So this going to be depicted exactly how the Q table is going to be maintained. So this I have been converted as such. Sorry. Right. So it's all going to be represented as a node, right? So 1, 2, 3, 4, 5. So the rooms have been converted as a node. The node has the links, because if you can see here, if there is a 0 room, a room number 0, will have the direct connectivity to 5? Definitely no. So 0 will have direct connectivity to which room number? 4. So that's what I have the you can go from 0 to 4, similarly 4 to 0. That's what these two arrow marks are representing. All right. Similarly, as such, we have completely converted or as a node of links. So you can see it is a kind of a graph actually. So if you look back as a data structure, it is a completely graph data structure. And what it is actually, it is a connected graph. See, if someone is not good at data structure, don't worry about it. All right. It is a connected graph. What actually the connected graph? And every node will have the connectivity to every other node. That is what connected graph. And in more further, I could say, in the node should have the direction. The node should specify the direction. So I could say it is the directed connected graph. All right. So this is not required for you, all those stuffs actually. I just want to exploit you. Okay. So you see here, I'll be giving a rewards. All right. I'll be, providing the value for all the state migration. You can see those that lead directly to the goal have a reward of 0. So which are the rooms directly knock out or directly reach out to the goal? What is the goal room 5? I could say directly 100. The rest I could put 0 because 1 will have the direct identity, so it is 0. Sorry, it is 100. 5 to 5, 100, and 4 to 5, 100. Rest all the values are 0. All right. So that is what the reward. All right. So let us assume that initially the agent travels from room 2 to 5. Let us assume that the agent is in room 2. So this is the agent position. So from here, the agent has to reach out to the target 5. Meanwhile, what are the intermediate stages the agent should take care, should go via to reach the goal? That is the actions. All right. So you just have a look here, like with the help of these state graph with value representation, with the reward representation. So we are going to construct the R matrix, or actually the reward matrix. Or stand for reward matrix. I could say it is a value chain. All right. So how many states that we have? 0 to 5, 0 to 5. When is there any movement or is there any transmission there? 0 to 0? No. If it is there, you can put that value. If it is there, if there was no state migration as such, put -1. -1 represents there was no such kind of actions. There is no such kind of action. -1 represent no such kind of action. So as such, you can see 0 to 1. You just compare this graph actually. 0 to 1. Do you have any connectivity from 0 to 1? No. So then -1. 0 to 2. We don't have any kind of direct connection to the node 2. So there won't be any actions, so I could put the -1. Similarly, you just take it out from 0 to 3. Do we have any direct connection from 0 to 3? No. So again -1. Do you have any direct connection to 0 to 4? We have 0 here. We have direct connection. What is the value of the 0 to 4? 0. And 0 to 5 -1. And as like that, you have to construct the reward matrix. Right? So this is the first step of the Q learning. The Q learning it's very simple thing. We want to create a Q matrix based on of the rewards. By that way, the Markov decision process or Markov a rule is going to be solve your problem. All right. So what we are going to achieve here is we want to claim as much as possible rewards. That is what maximization of the rewards. When you have maximum rewards, obviously that is the way is a good to solve your problem. All right. Okay, so the next thing is with the help of the Q matrix, sorry, reward matrix, we have to construct the Q matrix. You could see that is what a Q matrix. What is a Q matrix? We want to construct the quality matrix. So how the Q matrix are going to be constructed? This is the formula. Who has given this formula? Markov has given the formula. All right, that's it. So here, so we'll be taking what is the R actually, or is the reward matrix. The reward matrix, there will be a current state, and every state should have the action. What is the action is nothing but the value. The value of the action, sorry, the action is going to be represented by some value, which is what 0 or 500 or something like that, and plus gamma. So gamma is actually a learning parameter. What is the gamma? Is a learning parameter because there will be some factor which can be taken defaultly, because if some of the agents are learning very fastly, so for them we could keep the gamma rate is so high. All right. And if some of the if I put the very least gamma rate, which means that the learning ability is very less, which means that when the gamma is so closer to 0, right, the agent will have the immediate rewards, right? But when the gamma values, if you put as much as small, then the agents never learning, the agents never exploring. Because when the gamma rate is you, if you set the gamma value is so minimum, then only the exploitation is going to be happen, not exploration, not exploration, right? So when you want to claim as much as the maximum rewards, you have to keep the gamma value so high so that the agent will take a risk in which it claims the maximum rewards. I hope you got to understand. And moreover, in the note I have given how you have to choose the gamma value, because completely choosing a gamma is our own way. If you set the gamma is actually 0.1, which means that the agent never takes any risk, only it acquires the rewards which are so close to the agent. All right. Let me take this example. You can see here, when you set the gamma equal to 2, this fox only takes this rewards alone. It never tries this and this. Because why? Since you are setting the gamma parameter equal to zero point 0.1, so you are instructing the agent, or you are defining the agent movement, don't take any risk. Because even if you go here also, sometimes the tiger will be coming here, you'll be caught. Right? So always the agent will be in the safer side. When you are in the safer side, the learning never happens. That's the thing. So when you keep the gamma rate is so high, for example, zero point 0.9, so you are instructing your agent, go and claim all the rewards. So that is the gamma here, right? Int max of q of next state comma all actions. So after that, this gamma can be multiplied by what is the max, the maximum of all the next state with the possible actions. That's it. So you have to put all the way into this formula. This will help you to create a q matrix that I'll show you right away. We can see here. So initially you are in room 1. All right. What was your target actually? 5. So that's what you are going to create a q matrix for 1 comma 5. All right. So 1 comma 5. What is the 1 comma 5? This is what? This is 1. This is what? 5. So you will be finding this value. All right. So q of 1 comma 5, which can be defined as reward matrix of 1 comma 5. What is the reward of 1 comma 5? You just go back and find out the 1 comma 5 in the reward matrix. So 1 comma 5, the reward matrix, the value was 100. You take here, right? That is what this 100 came here. And what is the gamma that you have been considered? Gamma value is actually 0.8, which means that you are not use of the exploitation. You are going to perform the exploration, right? You are finding the you are going to take the risk in order to get the maximum rewards. That is zero point 0.8. Enter the max of q comma 5 comma 1. What is the q state of 5 comma 1? Who are all the neighbors of the 1? Actually, you can see here, these are all the adjacent nodes of the this 5. So the 1 is 5 comma 1. This is what 5 comma 1, and then 5 comma 4, and then 5 comma 5. So in which has the maximum rewards? You go back to the what it is, reward matrix, and find out 5 comma 1. See here 5 comma 1 where it is, it was cutted actually. All right. So you see here 5 comma 1 is 0. So 5 comma 1 is 0. So and 5 comma 4 is also 0, and 5 comma 5 is also 0. If all the things are 0, then the entire component gets 0. Then your 1 comma 5, the q matrix is going to be 100. As like that, you have to construct the entire q matrix here. All right. So this was the entire q learning step actually. That is what I have just told right away. You can see here. After that, I'll show you only the final q matrix. You can see this is the final q matrix. All right. So Q matrix constructed. So based on the Q matrix, all right, and which are the states will claim the rewards and which are the states will not claim the rewards. Based on that, the agent it starts, learning. That's it. So I'll be concluding here with the help of the Markov decision process. Inside a Markov decision, the quality learning table is matrix are going to be constructed with the help of the reward matrix. By that way, things are going to be happening. So this have been given a simple example for the reinforcement learning implementation. Got it? So um, that's it. I go for questions for reinforcement learning. I can here to answer all of your questions. Not only reinforcement learning, anything you can ask, I can answer you all. And Gargi, I just want to know, like, do we have any question today?
Yes, sir, we have a quiz.
Fine, fine. So, guys, if you have questions, you can post it. I can answer you. Once the QA has been completed, then I'll be handing over to the Gargi. The Gargi will, post the quiz link, and you can take and get fresh by the quiz.
So someone was asking, what is reinforcement learning versus unsupervised learning? So if you can tell some of the differences between these two.
Yeah, exactly. I think Misha is asking that questions.
Yeah.
What I've told, like reinforcement is a kind of learning mechanism which can learn everything from the environment, not to anybody. All right. So the only the surroundings are teaching. By that way, it starts learning and puts the learning effect into the next subsequent process. As such, the solving of the problem skills is keep on increasing. So the better example for that is you can see the game over here. So initial performance after 15 minutes, the games is getting so speed up and you cannot able to manage manually. Then after 30 minutes, the games are going to be fast and more, right? So this would happen only because of the reinforcement learning. Because in a machine learning, you cannot put like that because machine learning is always used to do this or that, or it gives the known answer. That's what I've told. All right. So that is what supervised. Even if you consider if you want to compare the reinforcement learning with the unsupervised learning, because unsupervised learning there won't be any target, just makes the group of items. That's it, right? Based on the similarity of the peoples, it will be grouping. So it is very much that it is very clear that if you have a 60 peoples of the classes, out of the 60 peoples, based on the marks or score or whatever it is, and based on that, you people are being categorized, right? So these are the set of peoples who are doing good, these are the set of peoples who are studying average, these are the set of peoples who are below average. So that is actually grouping. That is what unsupervised learning, because I'm not going to find anything over there. I just want to group the peoples according to the similarities, according to the learning similarities. Then I may take the necessary action. So how do I want to improve the below average peoples? For them only I could take the necessity action. So I think that would be the better discrimination of unsupervised versus reinforcement learning, supervised versus reinforcement learning. So in a nutshell, I could say like reinforcement learning always learns everything from the environment and then puts the learning into the subsequent level of the process by which it starts improving the performance. So the very significant applications are the game development, or if you want to, because a reinforcement mechanism should be embedded for the robotics, because the machine should learn itself and it should maximize the performance and when the robotics are speaking to the human and so on. I hope you got to understand. And I got some other questions. Please suggest some projects ideas to put for our college project. HM classic cartoon, like there will be a lot of projects are there. Like you can make you can construct like object detection. You can find out the video analysis. If you can do your project like if some object was there in the recordings, and after sometimes that particular object is not been there, like it was stolen, right? So you can able to detect product which is stolen, all right? So you can do like many number of projects. And Charles is asking, sir, could you please explain any real life example where reinforcement learning is implemented? Charles, like reinforcement learning, you can see all the gaming, right? So whether if you are if you have been played a game with mobile applications, right? In backend of the mobile application, the reinforcement learning was emerged, all right? So if you play from you, because if you are not taking any move which the machine doesn't know, that can be added, and then the machine strengthening the steps in the next time, all right? That all the application mobile games, all the games are the very good example for the reinforcement learning. Because when you are not playing with any opponent, when you play with as an opponent of the machine, then the machine can learn everything from you, because you are the environment for the machine, right? Machine learns from you and implement it, because predefinedly there was basic steps was loaded, given as a rule to the machine. Accordingly the machine starts playing. When the rule or when the any move which is not defined by the machine, which was played by you, and that will give a successful way of the solving the problem, then that move will be taken, and in the q learning that state will be updated by the reinforcement learning. As such, the machine plays wisely. Hope you got to understand. Is there any other question still? Abhijit is asking, sir, can you explain it practically using Python code? Yeah, I can do perfectly, but this is not the right place to, because if I start writing a Python code, I should instruct you all the packages, right? So what are the packages are going to be used? That is because we can do all the things in a next level of the programs, because we have been designed a curriculum, all the things in a greater practical implementations with the next courses. I think you'll be getting all the details, course details, from the Let's Upgrade team. If you have a time, just go through it. And even if you have anything want to be discussed according to the course content, you can chat with the Gargan. She'll be helping you out to what are the content, right? Anything else?
I think we can start with the quiz, sir. I think
Yeah,
all the
completely.
doubts are clear till now. Huh? I think we can
Yeah,
start with the quiz.
yeah. Go ahead,
So, guys, a
Gargan.
quick instruction as I always give for the quiz. Please try to post all your doubts during the quiz in the chat box, and also please be interactive during the quiz. So, anyone who is getting, a good position in the quiz after one or two questions, he or she can post it in the chat box of the YouTube. So, I'm just posting the link of the quiz. If there is any problem in accessing the link, you can just tell me there only. Guys, I have posted the link of the quiz. Please go through it. Anything? Anyone who is like getting the first or second or third rank in the quiz? He or she can just tell it here. Guys, please bring a message of either done or a thumbs up so that we can know how many of you are done with the quiz. So as soon as you're done, just post it here. Harshvardhan, can you elaborate your question? Guys, is there any problem with accessing the link? Like, okay, so someone is done with the quiz. Let me check, guys, if there is a problem. Let me check. So there is no like fault from our side. There is some issue with your network. For those like who are saying that the quiz is still loading, so please check your network connection again, and then you can do. Guys, okay. So you are done, but please try to tell me that what is your rank, and anyone who like secured first, second, or third rank. Ha. Come on, guys. Someone must acquire the first, second, or third rank, right? So I can see many of you are done with the quiz. Okay. Samir is first till now. Cool. First. Okay. Done. Uh, Someone is saying that link not found. Please check it. I have posted the link. Even the link is pinned, so please. Okay, congrats, Chirag. So many of you are at the first position, right? Okay, now third, no problem. You can try. Guys, please don't forget to post your doubts. Any question which you find difficult, you can just post it here. Okay. I think we're done with the quiz. Or like many of them are done with the quiz. So we'll start with the query session. Guys, please post all of you like done with the quiz. Just post it so that I'm not getting the
Yeah,
we'll
okay.
resolve the issue.
Jackie, I think your net was weak. Please rejoin.
Is my voice okay, sir? Like, is it breaking?
No,
Yeah, it's breaking.
your voice is breaking. No issues. I can take the questions, Gargi. You take
Okay.
just relax. Fine.
Thank you, sir.
So,
Sure.
HM Classic Cartoon is asking what would be the difference between data science and data mining. So the same algorithm, if you have been learned before 2 decades, it was data mining. Now the same algorithm can be referred as a data science. So due to the enormous growth of data, the same algorithm is being referred as a data science technique or algorithm. That's it. Apart from that, there won't be any differences because the same algorithm what you'll be studying in data mining, the same algorithm we are going to use inside our machine learning or data science, right? But one neat thing is those days we lacked with data, and today we are completely having the unimaginable volume of data by which you can find a lot of interesting patterns or observation over here. That would be the only difference between data science and data mining. That's it. And I got some other questions from and classic cartoon. If you're not happy with the answer, again, if you can post it specifically, I can answer you all. And let me take up the next question is Ashavardhan. What is PCA? So PCA is a principal component analysis, which means that when you have 100 features, always not 100 features have the have are not contributing to come up with your results, right? So PCA is used to identify only the significant features, which means that only the feature which makes the more impact towards your outcome, those features I could say significant. So PCA is used to extract or to identify only the significant features. It will just drop or omit the insignificant features. For that reasons, we'll be using PCA. I hope your question has been solved. I go with another questions. Yeah, same. Kirti Jain is asking PCA. I've answered for that. Again, Ashavardhan is asking what is PCA. I've just answered. So if you still have any doubts in it, you can post your questions. So I'll be waiting for your questions. And PCA, there will be a two thing actually. So PCA and LD. PCA stands for Principal Component Analysis, which exclusively will be doing for unsupervised learning, which means that when you want to cluster, when you want to deal or analyze anything without the target, if you want to identify the significant features, then go ahead with PCA. Yeah, Ashwardhan, that's what I'm telling. So you are asking then how it comes under unsupervised learning, because it never, because people have been defined as such, but it is not. It is not limited to applying the supervised learning, because PCA is only extracting the variance or significant level only in the features. But that's the reason why we keep PCA under unsupervised learning. But whereas there is another technique called LDA, right? There is another technique called LDA. So linear discriminant analysis. LDA stands for linear discriminant analysis. So this LDA comes under supervised learning. Why? Because if you have a features called X1, X2, you have a target. All right. So this LDA will identify whether X1, how much of impact the X1 will be creating to come up with your outcome target. So I could say 90% X1 makes the impact on the outcome. 10% only X2 is contributing to come to deriving the outcome. So out of which as playing the maximum role 90% X1 itself, because without X2 even you could use only X1. Without X1 you can come up with the results. So this can be analyzed. The feature selection is going to be done with the help of LDA if it is a supervised learning. What actually the unsupervised learning? So let us take the employee salary or student marks, right? So we don't have any target here. You have simply values. So what is the significant level of this particular features to make the groups, right? Because we want a group here, right? So you have we want to classify two groups, 10, 11, 20, 20. 10 and 11 will be in the one group, and 20 and 22 will be in the another group. So this feature, what is the significance of these features? So you have only one features. You can have employee salary and what is that? Years of experience. Years of experience. Based on both the features, you want to make the people into the different groups. So you have to identify what is the significant level of this employee salary for grouping your entire component, right? So to do this task, you can make use of the PCA, right? That's the reason why PCA can be classified or can be put under unsupervised learning, and LDA can be put under supervised learning. But if you want, you can make use of the PCA for this also, but when you want to work with LDA, definitely you should specify the target. All right. So, but PCA can be applied in both supervised and supervised, but the people have been categorized under a unsupervised learning. I've given the reason for that. Okay.
Sir, I think we can go like with the questions again of the quiz, because I think there was some doubt with the last question. So if we can go with the quiz questions again, that would be beneficial for all of them.
Sure, sure. After going with the
Mhm.
first questions, I can come up with the question they have been posted. Just a second.
Yeah.
What is the last questions? Or else should I play? 1 minute. I don't know what would be the last questions. That's what PCA is. They have been asked. So PCA is supervised classification, unsupervised classification, semi-supervised classification, all of them. So it is an, if you say directly, it is the unsupervised classification. All right. That answer for the last question is unsupervised. That's what I have been explained so far. I hope you all have to have got the answer for the PCA. PCA is used for, which is not actually designed for a supervised learning, which is actually designed for a unsupervised learning. So of course, PCA can be used for unsupervised classification. That's it. That is the answer for the last questions. Okay, and have a lengthy passage by the classic cartoon. I go with that. Does the efficiency of the classification algorithm for a particular data set depends on the system performance? Because every single algorithm have variation in efficiency. Like HM classic cartoon, like the performance of the classification algorithm is not directly dependent on the system performance. See, when you have the very good highest configuration of your machine, then your algorithm runs fastly. So here only you could maximize the training time. Of course, when you go to the deployment of the real time problem, you will be having the very highest configuration of the machines, of course, right? So here we are not bothered about the system performance, because obviously when you want to work with such kind of big high computing algorithm, you should keep the very high configuration machine only. Like you should have 30 GB of RAM, you should have the large amount of memory, and you should have the very greatest processor, right? So here the performance of the machine learning algorithm only can be calculated because based out of the data, based out of data, how the algorithm is performing for it, right? So of course the overall performance includes the training time of your model, but apart from that, but you if you change the highest configuration of the machine, obviously the training time is going to be reduced, but the performance, the accuracy of the how accurately the model are going to be classifying, that cannot be changed even if you change the high performing machines also. So the answer for your question is definitely based on the system performance, your algorithm never changes its accuracy, right? So when you want to change or optimize the accuracy of the model, how correctly it is doing, that is accuracy, right? How correctly it is doing your model, how correctly your prediction is matching with the actual real data, So that is purely based on the data and the algorithm what you are selecting, the right algorithm, the good nature of data. So this combination of the things will create a better outcome. Hope you got to understand. Then I go with Shai Nandi, done, confused about supervised, unsupervised. Good, you got cleared. Okay, Ashavardhan is also said, thank, he got it actually. And sir, can we get these questions? Of course, all these are in the live only, right? So you can go to the YouTube, you can just watch a number of times. So you can take all the questions from the video chat itself. That's it. So I done the questions. And one more thing. So I thought of starting the neural networks or deep learning today, but almost the time up. So because it is a very big topic, right? So we can start that deep learning model on tomorrow, because that is the only one model which is left out actually. So and tomorrow we'll be discussing entirely how deep, because not entirely actually, a deep learning is like a ocean. So I'll be giving uh, brainstorming for you all right. So I'll give the initial basic things for you to ignite, to came to understand what exactly the deep learning. All right. So how we have been learned today about the reinforcement learning, similar way I'll be taking all into the tomorrow session on the topic of deep learning. All right. So meanwhile, I can wait for another couple of minutes or 5 minutes of the time. If you posted another few more questions, it would be great. Welcome. It would be welcome, and I'll be answering for you all. Abhijit says, thank you, Ashavardhan. It was fun. Okay, hope you have enjoyed. Okay, welcome Ashavardhan, and welcome Classic Cartoon, and welcome John Avarti. Okay, I think
So I think yes, they don't have any more doubts, so we can wind
yeah,
up with the session. Hmm.
yeah, of course, greatly.
So yeah, we don't have any other doubts. So thank you so much, guys, for attending the session. Thank you so much, sir, for providing the valuable information. A quick recap of the whole session. Today, we learned about reinforcement learning. We studied about the aspects of reinforcement learning, that what it is, how can we implement that. We studied about penalty and like awards whenever a agent like gets a penalty or a reward, then how the agent should learn from that. So this was about the reinforcement learning, and then we like started with the queries of the quiz. We discussed about PCA and supervised and unsupervised learning again. So I hope all of you enjoyed the session, and thank you so much, guys. Sir, we can end the session here.
Sure. Thank you so much, Gaki, and thanks to everyone. We'll be meeting on tomorrow. Bye bye.
Thank you, sir.